all this means is that you can have more than one physical phase of the same element. And carbon is one of those guys that does this. He's not the only one. You're going to see when we get to kinetics chapter, I'm going to talk about phosphorus does this too. Other guys can do this. But another way that carbon's unique. Remember what this first chapter is about. It's all about the atom carbon and how he bonds to things. And this is involved. The bonding is involved in the reason why this guy is what he is, why he has different forms. And this is going to be a much simpler day here today than what we've been doing. It's going to basically be notes that I would ask you to spit back at me. All right, so you understand the difference between it. And it's kind of more memorization than understanding. All right. What's that? You think a picture of?
Diamond.
Yeah, like Superman, right? You take a lump of coal and you squeeze it real hard and you make it into a diamond, right? What is a diamond? A diamond is just, I don't know if that really works, by the way. I'm not Superman, but I do play him on TV. No, I don't. But yeah, basically, I know it's very hard to believe this, but a diamond is nothing but pure carbon. Not carbon and hydrogen bound together in some compound. It's just the atom carbon bound together in a specific way. Okay? Diamonds are forever. And diamonds are a girl's best friend. But diamonds are also one of the 3 allotropic forms of carbon. Okay? They have sp3 hybridization, as you'll be able to see from your picture that's on your paper and from the picture that's going to be up here in a second. Look at any individual carbon on there. How many things are bound around each of those individual carbons? If you look in the middle, the center.
2.
No. 4. There are 4 other carbon atoms bound around each carbon. They have a fixed tetrahedral interbonding of all carbon atoms. Isn't that a great phrase? I love that phrase. Really makes it sound like you know what you're talking about when you say you've got a fixed tetrahedral interbonding of all the carbon atoms in the allotropic form of carbon known as diamond with sp3 hybridization. Geez, it sounds like I know what I'm doing, even though I'm clueless here. All right. Now, the properties of a diamond, I don't think anybody's going to get wrong. We all know what a diamond looks like. It's clear, it's hard, it's a crystal, all right? And it's completely different from the other allotropic forms of carbon. Doesn't look at all like it. Which I don't have on the paper you have there. I'm going to pass it. Well, actually, I did give you all 3 papers, so it's on the next paper. Don't flip there yet. Let me ask you. By the way, here's the picture. There it is. So every carbon should be bound to 4 other things that we all just learned over the last 2 days means these sp3 hybrids. Let's take a look at the next guy. All right? Look at the bonding in this one. Next page. The one that has that picture on it. Okay. Oh, and by the way, this is why we have a 3-ring binder.
I know I forgot mine.
Paris!
Oh, I have
It's
one.
not you. I'm just making fun of you. Now, look at how many things are bound around the carbons here. Now, granted, it doesn't go out for infinity, but how many things are bound around this central carbon? 3. Which means, it doesn't show it on here, we have sp what? 2 hybridization. There must be a double bond in there somehow. And above and below are going to be some p's, that were unused. Now, the thing about that is, what you end up getting in this form, which, by the way, is right here. I have quite a few things to pass around to you. I have some of this stuff here. This stuff is completely different than a diamond, as you can see. Let me show it to you. Okay? I'll put some on this watch glass. I'll show it to the folks back home, the audience at home. And hold on, make sure it's dry. All right, put some of this stuff on here. And I don't know if you can see the title of this, but there. Wait, can you see on the camera? Probably not. I'm in the way. I don't know. Whatever. It's black! It's not clear! Not being racist. Everything's racist for you guys. It's black. It's not clear. So that's a big deal. It's not hard like a diamond, like the hardest substances. It's soft. I'll pass this around. You can take a look at it. And we use it. Everybody, I don't have to pass it around. You're all using it right now.
Lead.
Oh my God.
Oh my God.
Yes, the other allotropic form of carbon is lead. What are you, an alchemist?
I can be.
That would be funny if you would have and if you knew why carbon can't be lead at the same time. But no, y'all call them lead pencils. They still call them lead pencils. They're not lead pencils. What is in your pencils? Graphite. Graphite. Pass that around. Okay. Well, I guess we're not using this video. Lead! It's not lead, it's graphite! What are you? It's the same. Oh, God. Look at let me just explain to you why this is such a bad answer. It's kind of like someone asked you what your pet was, and your pet was a cat.
Maybe a dog.
And or a dog. Okay, it could be a dog. And then then somebody said, "Oh, I have a pet just like that. It's a grass cutter. It's a lawnmower." They're not even in the same family. They're not the same. You can't be a lawnmower and a cat. All right. The other form, I could have different kinds of cats. Maybe a better example would be what kind of cat you had. Like I have a Persian cat, or I have a tabby, or I have a Siamese, or I have a grass cutter. It's one of the. It's not. Lawnmower's not a type of cat. Lead is not a type of carbon. They're totally different things. I guess this one's not. We gotta hope the next class goes better than this. All right. So anyway, my point is this: why is it that carbon in the second form doesn't have the same properties? Carbon has graphite, has sp2 hybridization. That's why it's totally different kind of bonding, which results in a totally different kind of properties. They're not the same thing. But it is pure carbon. It's just carbon bound in a different way. The sp2 hybridization, the atoms are arranged in planes. This sp2 hybridization, they're all bound very, very tightly together, but the individual planes above and below each other, they're able to slide past each other, which is why we also use graphite as a lubricant. It actually used to be added, I don't know if it still does, you could add it to motor oil, for example. Graphite can be used as a lubricant. You ever get your key, it's not turning right in your car, you can spray graphite into the lock, and that helps sometimes, they say. I'm not saying you should do that. Probably gunks it up. Graphite is used as a lubricant on chains because these things slide past each other. Also, graphite is used for golf clubs and tennis rackets. Why? Because it has a very strong tensile strength this way. So, God, relax. All right. So, my point is the properties are different because the bonding is different. Okay, this guy's a soft, black, opaque powder versus a clear, hard diamond. Not the same thing. Okay? All right. What's Oh, Pakwe. That's an Indian tribe, the Pakwe. They raided Custer, that little big one. They had repeating rifles, so they were able to defeat it. The Pakwe. Opaque! Opaque! The word's opaque!
What is it?
Oh my God. This has got to go on the blooper reel. And what does opakwe mean? It means you can't see through it. I can see through Lexi's skull if I look through one ear, but out the other side, because it's not opakwe! Okay. Wow. This is what class is this? Tell everybody at home what class this is. AP Chemistry. And this is what I've got to deal with. Okay. Opakwe Siamese cats. Made of lead. All right. When I first started teaching, back when there were horse and buggies and, the Indians were raiding Custer, the Opakwe Indians. Back in those days, I would stop here because that was it. My first textbooks when I was in school, and even when I first started teaching, there were not 3 allotropes of carbon. There were only 2, graphite and diamond. Since then, we have discovered in the last 30 years another one. That one. FIFA. The FIFA. Why FIFA? Soccer, right. All right, no. It looks like a soccer ball. Matter of fact, I have one right here. Not a soccer ball. This is it. In real life, that's a real carbonate. I'm just kidding. It's not a real carbonate. I blew it up. It's like Honey, I blew up the carbon atom. Honey, I blew up. By the way, this guy is called a buckyball. Buckminster Fuller, which was very awkward when I had a kid named Bucky in class, and you're talking about buckyballs. It got to be kind of.
Is that really what they call them?
It is. I say it's called buckyballs. It's named after Buckminster Fuller. It's named after Buckminster Fuller, who actually designed a lot of those geodesic domes you may have seen. They were big. They were popular in the 70s, I guess, or 80s. I forget, maybe even 60s. I'm not an architect. But they were used, perfect example is the Epcot Center, right? You've all been to Epcot?
Yes.
That's a geodesic dome, okay? It's named after these guys, and I have a job for you. I am not giving you this information. Your job is going to be to find it out for me. Your job is to find out for me the following information. I'm doing some research of your own. Okay, you have to research the following things about this with your own computer. By the way, are those computers even working yet?
Nope.
Well, either way, at home, I don't care when. Sometime in the next week, I'm not going to give you class time to really do it, but sometime over the next week, you're going to want to look up the structure of the buckyball. Explain it to me. Obviously, it looks like a soccer ball, but you got to go beyond that. What kind of hybridization is in it? What kind of bonding is in it? How many atoms are in it, for example? Okay, and finally, the history. It's a very interesting story. If you look up the history of how buckyballs were discovered, it's actually kind of neat. And I will ask you, I will guarantee, I'm telling you a question on the test, one of the first questions in the test. You ready? There will be an essay question on the test, and it will ask you about buckyballs. This question will say either describe how buckyballs were discovered, or describe the structure and bonding, or possibly even the uses of buckyballs. And it will be a short answer question. I'm not saying it's an essay question worth 20 points. It's going to be a short answer question. It will not be worth just 1 or 2 points, though. It may be worth 5 to 10 points, all right, depending on how, and I may ask more than one. I may break it up into different parts. But it will be on the test. It will be about this, and I will not cover the discovery of it, the uses of it. That's for you to find out, okay, on your own. Okay, I'm not quite done, because the last thing I have a little demo for has to do with the last different way of putting carbon together. Take a look. Something called amorphous forms of carbon. Now, you have not let me down all day today. Let's see if you can not let me down again when I ask you, what does the word, quietly, wait, because we saw amorphous before. See who remembers what amorphous means. Raise your hand. Oh boy, go ahead.
I don't know how to explain it, but it's like an amphibian. It can be like in water.
Amphibian can be water. It has nothing to do with this. That was amphoteric. You're thinking of amphoteric when it came to acids and bases. Good partial memory there. That's a good one. Haven't had that one yet. Well, let's break the word down. Amorph. A in front of atypical. What is that? A in front of something means what? Not. Okay, so not
Changing.
Changing. Oh my God, it's not changing. Morph doesn't mean change. It's not the Mighty Morphin Power Rangers. Okay? Morph means shape. Morphing is to change shape. But amorphous means no shape or no definite crystalline structure. We had amorphous, remember? Glass, butter, plastics. Remember we talked about solids, crystals? Remember I said there were amorphous solids that don't have a true crystalline structure? Remember that? I get nothing. I'm getting nothing. I'm getting nothing, people.
I remember that.
Do you remember that?
Yeah.
They're lying to me now.
No, I remember that.
All right, well,
Was my least favorite.
crystals were your least favorite. I remember that. You were walking around the back there. You were clueless.
I
You didn't
got
even-
101 on that.
Yeah.
Because
That's when I had you crawling on the floor.
Anyway, so no crystalline shape for carbon, which means I basically have destructively broken up carbon in some way that I've broken the bonds up in kind of mishmash ways, and I don't have buckyballs. I don't have graphite. I don't have diamonds. I've got a whole bunch of carbon that just kind of got broken apart when I burn something incompletely. Usually, that's what you get it from. Like when you get charcoal, bone black, activated charcoal, coke. Oops, don't put that down. Oh, I'm sorry. There we go. If I burn things without enough, because if I burn carbon, like say for example I were to burn this graphite that I have here. If I were to burn this graphite, and it will burn, as you may remember, graphite. Hey, who remembers the Chernobyl problem, right? What was the problem with Chernobyl's moderator? Was it water? It was graphite. What happened when it got out of control? Caught fire, blew up, caught fire, burned for days, right? Graphite burns. And if I have enough oxygen around, it burns completely. And if something with carbon burns completely, what do you get? Carbon and oxygen, burning oxygen, right? What do you get? Carbon dioxide. If you have not quite enough oxygen around, you might still get some carbon monoxide. And if you really don't have enough around, you might get this. Okay? Just a whole bunch of, this, charcoal, which is still charcoal. Here, this is wood charcoal, right? And it's been powdered. Okay, here's some wood charcoal that's not. Like charcoal briquettes, you might put on this. You wouldn't put this on a fire, but this is wood that hasn't been burned completely. So what I've done is I've broken some bonds, so they're no longer bound together. And there's probably, by the way, charcoal also has other stuff in it too. It's not just pure carbon. A lot of times, if you're burning wood, there's a lot of other stuff in wood besides just carbon. So we've got wood charcoal. This is activated charcoal. You know what activated charcoal is? Activated charcoal is just charcoal that has a whole lot more surface area. And I have a little demo I'm going to show you for this. How much time do I have? What's the period? 49? 49? Really?
Yeah.
What? Like I have 20 minutes yet?
Yeah.
Jeez. Okay, well, I got no rush then. What? Coke. That is another, same kind of stuff. They would. No, go. All right, cocaine. No, it's not that kind of coke. That kind's white and makes you feel good. No. This is, they actually use it in the steel industry because it burns hotter and you get, you basically use it to melt, well, not just melt, but steel has to have some carbon in it as well. And I don't even know, I'm not an industrial engineer, but it is another form of amorphous carbon, like charcoal, pretty much. It does burn hotter, I believe. Anyway, my favorite one is bone black. You can get this from not heating these things up incompletely, right? Incomplete combustion from these things. And I said you could, anything that has carbon in it, you could do it to. Wood, you could do it to, right? You can also do it to animals. Fluffy. Yeah, that's what happens to Fluffy after you drop him off when he can't. Poor Fluffy. So I don't know what pets are in here, but animal charcoal or bone black. All right. Which, by the way, I guess bone black, bonfire. These are burn bones. If you burn bones in a bonfire, you get bone black. That's where bonfire comes from. Did you know that? Bonfires didn't start with football games. Bonfires go back to I think the Middle Ages or earlier, where they would have to. There's so many people were dying and didn't have any room in the cemeteries. They would just have to burn. Have a bonfire, a bone fire of old people, so they make room for new people. Make room for new dead people to go in the ground. Yeah. Anyway. Hey, I got a little demo for you. You want to see it? All right, good. Because even if you don't, I'm showing it to you. Activated charcoal, which I want to make sure you use the right one. I don't want to use fluffy. Activated charcoal, I'm going to put into a container here with something else. Here, turn that light on for me, because you're going to need to see the colors here. Take a look. I have some water, actually. Add some food coloring to it. You watch it. Take a little green food coloring, and I'll show you what one of the uses for activated charcoal is. Okay, so Put a little food coloring in there. You can see that's green. See? Oh, there you go. Okay, see, green. This is a nice dark colored green. I'll add a little bit more water to it just because. All right, now I'm going to take some. Where'd it go? Here, activated charcoal. Watch it. I put some in there. Let's get this over here. Take a little activated charcoal. Put them in here. Maybe a little more. Put them in here. You're going to tell me what they use this for, perhaps. Maybe not. The way today's going, I'll be shocked. Put my lid on. Always does this. It always forms like a... There you go. All right. Shake it up. Okay. What do we use activated charcoal for? Anybody know? Ever hear of it being used for anything? Nobody? You all probably have it either in your fish tanks, your refrigerator, under your sink, or your shoes. What's that? No? Come on. What is a fish tank? Your shoe inserts, your sink, your refrigerator water in a Brita have
A filter.
a filter. Exactly.
What is a shoe? A shoe?
Odor eaters. Odor eaters. You don't use them anymore. Yeah, I don't wear them because my shoes don't stink. But yeah, look, activated charcoal has a lot of surface area. Charcoal happens to absorb things pretty well to begin with, but you have a lot more surface area, about 1,000 times the surface area of regular charcoal. It will absorb things, including impurities in your water. So like most of you guys probably drink filtered water, I'll bet you. At home, you have a Brita filter, one of those little, what do you call them? Pitchers that you put them in, or you have under the sink filters. And I said fish tank because your fish tank has a activated charcoal filter as well. And I said shoes because your shoes, I'm sure you don't wear them, but some people should wear your activated charcoal shoes because your feet stink. I'm not saying no, Lexi, but some people do have smelly feet. So anyway, now you say, well, I don't want to drink that. Let's say the impurity was that green stuff I put in here. I don't want to drink that. Well, you have to do something else. You have to you have to run it through the activated charcoal. Did you ever use one of those filters? When you first use it, what does it look like? It looks like that. This black stuff goes through it, right? Well, you got to filter that. So I have a filter here. Okay, I fold it up. You're about to fold it in half again. We did this last year. Make a little opening. Okay. Get this wet. Put it in a filter. Put it in a funnel. The word's funnel. I can't think of the word. Okay, I got it. All right, now I got this get a little bit higher so the people at home can see this. I'll use this. Don't do this at home. Here I am saying it. Don't do this at home. Do not rearrange test tubes at home. All right, is that high enough? High enough. Now, I'm just going to pour this through here. Now, if I did it right, which I probably did, what will happen is it comes out without the green. The green's gone. See it? It's clear. See? And that's what it does to your, can you see that? Can you see it? Okay. And that's what it does in your water filter. Okay? Same thing. You run the water through that, it takes out the impurities, and it comes out nice and clear. Isn't that cool? Where'd the green go? Is that like what?
Is it like safe to drink if you drink that?
Well, it would obviously no, because it's in a filthy, dirty Erlenmeyer flask. Yeah, but yeah, sure. If I could do that if I had my own. Yeah, that's what you are doing. I think a lot of times you guys don't realize that. It's like when you're eating meat, it used to be a cow, and when you're doing this, what I do sometimes is a small scale thing in class. People don't realize that's what you're actually doing when you're driving your car. You're burning a fossil fuel. That's what's happening. You're just doing it in a controlled way and in a larger way. All right, same thing's happening here. Your filters, whether it's an under the sink filter, a fish filter, or a Brita filter, is doing the same thing this is doing. Just taking the impurities out like that. Okay? All right. Okay, I better stop this. Not that I'm ever using this one again. This is getting burned. I'm going to burn the tape for this one. But you have to finish the rest of that packet.